big new idea is what we call the chain rule. And another way to think of it is it's called a function inside a function. And it's how to take the derivative of that. And can you see that okay? Is that showing up?
Yeah, it's all right.
It's all right? Okay. So here's what the chain rule is about. If I gave you y equals 3x minus 1 to the power of 7, and I asked you to find the derivative of that. So what is dy dx, the derivative? What you realize is, what you should do, or what we know how to do right now, is that I would have to multiply this all out so that I can then take the derivative of each part. But to the 7th power is clearly going to be a very long expansion. And so basically what we figured out is, and when I say we, someone way back when, figured out there's a different approach, gets you the same answer. And it's going to involve a step of substitution. And so the chain rule, again, it's the idea that it's a function inside a function. And I'm going to come back to that idea over and over. So the first thing when I look at this, your formula booklet says that the derivative, or the chain rule, is what they say is du, dy, backwards, dy du times du dx. So the derivative of y with respect to u, which we've introduced a new variable, times du dx. If you think about fractions, these will like cancel each other out, so yeah, we have dy over dx. So, step 1. Identify the two functions, okay? So you're going to identify the two functions. And here's where I go back. So what function is inside the function? And 9 times out of 10, you're going to have a bracket and something inside that bracket, which itself is a function. So my u, and here's the first thing I'm going to figure out. The function I put inside is 3x minus 1. So there's my u. And I put 3x inside the function y equals the bracket squared. Okay, well, what's inside the bracket? Well, I'm not going to write 3x minus 1. I'm going to write u. Now let me pause there. Any questions about what I'm thinking? Okay, silence, I'll take as no questions. So I have this function, 3x minus 1, inside the function of something to the 7th power. And so now I look at, so what's my formula say? It says, well, what is the derivative of y over u? And if you think about it, dy dx is because we had the variable x. I'm now saying dy du because we now have the variable u. And this is nice. 7u to the 6th. Done. Then the second part of the chain rule is the derivative of u with respect to x. And so I'm looking at my u function, the derivative of u with respect to x. So du dx, what's the derivative of 3x minus 1? It's 3. And so now I can come back to the formula, the way it works, and what I see is I have dy du 7u to the 6th times du dx 3, and so this is equal to 21 u to the 6th. But we're talking about dy dx, so I now go back and resubstitute for u to say that this is really 21 3x minus 1 to the power of 6. And that is the derivative of y with respect to the derivative of x. The good news is you do not have to multiply this out. This is its cleanest, simplest form, and so we're going to leave it that way. All right.
So in our answer, if we went through this methodology and we came up with that, that would sort of like the full marks that they're looking for?
Yes. Okay.
You said 9 times out of 10 we would get the equation, the function in the brackets, but what's the 1 out of 10 chance?
I'll give you that in a second. Okay? So, but first we kind of see the process. So if I go back, because I was talking, so step 1, identify the two functions. Step 2, take the derivative of each. So right here is my step 1. Right here is my step 2. My step 3 is to multiply the results. Step 4, replace u. And so, right here is step 3, and then step 4. Okay? So, with that in mind, what I'm going to do is, give you 4 examples and just talk them through. And then, yes, you're going to be doing, obviously, practice problems on your own. But after these 4 examples, if there are no questions, then I'm going to jump into the next idea. So, sorry. So, next equation is y equals 2, 1 minus x cubed. Okay, let me make it slightly more interesting to the 5th. So step number 1, someone open up your mic. What would you say is the function inside the function? What is u? Yeah, go ahead. Somebody shout it out.
1 minus x.
1 minus x. So what is my new y function?
2 times u.
Yeah. 2 times u to the power of 5. So there's my step 1, my 2 functions. Step 2, take the derivative. So dy du, I'm going to start from the bottom and kind of work my way up. 10u to the 4th du dx is just -1. So 10u to the 4th, derivative of 1 minus x will just be -1. So now I'm ready to say that it's 10u to the 4th times -1, -10, u to the 4th, and now back to dy dx equals -10, put back in my x, and there's our derivative. You can shout out if I went through that too quick. All right, no shout out. Again, pause me, ask a question as I go along. Yeah, we are trying to run class. But again, step 1, step 2, multiply together, substitute. 4 steps. Next example is going to look like y equals x squared plus 3 to the 4th. And someone tell me, what is u?
Sorry, what you is oh, never mind. Sorry, I was
Yeah. Let's see. Let me pick Grace. Grace, what's u? Yeah. 90% of the time, what's inside the parentheses? Are you there?
x squared plus 3.
Yeah. So, x squared plus 3. There's my u, my y, u to the 4th. Derivatives of each. Again, I'm doing the bottom one first, dy to u, 4u to the 3rd, and then du to dx, 2x. And now, come back over, we have 4u to the 3rd times 2 to the x, which is equal to 8x u to the 3rd. And now substitute back my u. And it's x squared plus 3. And, sorry, to the 4th power. No, 3rd power. What am I saying? Sorry. And again, this is simplified version, done and happy. Are we feeling okay about this so far? Yes, sir.
Say, for example, if the x squared plus 3 had 2x squared and became 2x squared plus 6, would you take out the 2?
No.
So you just leave it there?
Yeah. I'll add another example. Sorry, say again?
My bad.
No. Let me give you another example of what you're talking about. And then, because we can try and make it more and more complicated, but we'll see. Now, so this next one is the square root of 8x cubed plus 2x. So here the question is, what's the function inside the function? And let's see.
I think I have an idea.
All right. Go ahead.
If it's easier to visualize, because we got used to visualize the differences in the power, you could rewrite the whole thing in the power of 1 half.
So, yeah.
Brilliant.
Step number 1, square roots, cube roots, roots, whatever, rewrite as into their exponential form. That way we can apply the rules that we know. So the function inside the function is 8x cubed plus 2x. The function y, my new function, u to the half.
Wow.
So there's step 1. Step 2, derivative of u to the half is 1/2 u to the negative 1/2. The derivative of u, 24x squared plus 2. Multiply these two together. Now, you have to realize it's that times 1/2 u to the negative 1/2. And just to make life easier, let's rewrite this as 1/2 u to the half. Is that okay?
Yes, sir.
All right. So now we have, because it's 1 on top, x squared plus 2 over 2, u to the half. Yes, we can simplify that even further. Running out of board space, dividing both by 2. 12x squared plus 1 over u to the half. Substitute u back in. And my half, I'm going to change back to the square root. And we're done. And I'm not looking to simplify that any more than it is. Any questions there?
Mr. Nina,
Uh-huh.
is it possible if you could please use a different color because the green's kind of hot?
Yes. Thank you for telling me. Anything else?
Black lines is green to the picture. You can see.
Sorry, I couldn't hear that. I need to turn my...
The black mark is fine. It's just a bit hard to really see all the powers and stuff.
Okay.
Fine.
All right. I'll stick to black and hopefully blue will show up. All right. So this is kind of one of the first cases I said you don't see a bracket here, but the square root, essentially changing it to exponent, turns into a parentheses.
It's slightly unrelated, but since the school is looking for more things without doing a lot of people like it, that just said that we're going to be a lot of the stuff is going to be on our box desk, or is it similar information what we had before?
Yeah, no, none of this is on your mock exam, because I wrote it prior to all of this, and I'm not expecting to, change or add anything onto it. Okay? Now, all right, let me get rid of all the green. Before I see that? Can you see this blue?
Yeah,
Yes.
yeah.
Okay.
Sort of, yeah.
Sort of. Yeah. I'm going to just make it black. All right, so here's your new and last example. 1 over 3 minus 7x. So what's the function inside the function? Let's see. Who haven't I really heard from this morning? Aldrich? What would you say is function u?
Three squared minus 7x.
Yeah, there's no square, it's just 3, but you're right. So it's all this 3 minus 7x. And so my new y function, Aldrich, what would you write as the new y function?
Y. I mean, 1.
1 over u.
Okay.
Because we're calling this u, and so our new y function is 1 over u, which, we're going to call that u to the negative 1.
Okay.
And now, the derivative of u to the negative 1, negative 1u, u to the negative 2. Derivative of my u function, 3 goes away to 0, negative 7x, be negative 7.
My definition here, but is 1 over u. What's the sign next to 1 over u when it's y equals?
Here, u to the negative 1.
No, the one sign before in the middle of the two numbers.
Oh, here, equals.
Yeah. Oh, okay.
Sorry. And then now back over to my formula, which says negative 1, u to the negative 2, times negative 7. So my two negatives will make this just 7, u to the negative 2, which is 7 over u positive 2, u squared. And now I go back and resubstitute. Three minus 7x squared. We okay with this one?
Yes.
Yeah. Because I'll kind of pause for a second just to let you look at it, think about it, and ask a question if you have it. All right. Well, so that's the chain rule to start with. We haven't talked about trig functions, we haven't talked about exponential functions, but you can imagine if you will, that we could have y equals sine of 3x squared minus 4. And what's the derivative of that? And we will get there. We haven't talked about our trig functions yet, but just to let you know, that's coming up along the way. Okay, we still apply these ideas, but there's a extra step or extra thought when we talk about trig.